As some of you may know, I'm kind of crazy when it comes to power efficiency. I've made an entire video about optimizing my server's power draw and managed to get it down to 23 watts on average, which is pretty good for a rack mount server with 44 terabytes of raw storage and a 10 gigabit networking card. However, many people had a better idea, at least in their opinion. Why not just use an M1 Mac Mini? Using Mac Minis in a home lab is nothing new, and the relatively new ARM-based M1 Macs blow the previous models out of the water with their amazing power efficiency and performance. Plus, as time goes by and newer models come out, there will probably be a ton of great deals on used M1 Mac Minis on sites like eBay, Craigslist, and so on. Well, the bad news is that I don't own an M1 Mac Mini, but I do own an M1 MacBook Air, which has the same chip, and the only thing that it lacks is an optional 10 gigabit Ethernet jack. But I do have a solution for that. And even though the MacBook Air isn't as small as the M1 Mac Mini, it will do just fine as a proof of concept. And spoiler alert, a concept is all you might need to decide against using one of these in your home lab, especially if you plan to use it as a NAS. I've had my MacBook Air for more than a year now, and it has served me well. It has 16 gigs of RAM and a 512 gig SSD, and in the typical Apple fashion, both of those things are soldered onto the motherboard and can be upgraded. Because I store all of my original footage, I need a relatively big storage array, and with its 512 gigs of internal storage, the M1 MacBook Air won't be able to adequately replace my main home server. And since M1 Macs don't have any SATA ports, that meant that I had to get creative. I could of course just do it the iJustine way and edit off of a bunch of external SSDs, but that would be just too much jank for one video. So instead I reached out to TerraMaster and they agreed to send me this. This is a D5 Thunderbolt 3, a 5-bay DAS or direct attached storage. A DAS is kind of like a NAS, but without the computer part inside. Instead, it has a PCIe RAID card and a Thunderbolt controller inside, and all of that is connected to a computer via a Thunderbolt cable. And if you don't actually need a home server that runs 24/7, if you just need a lot of storage for something like video editing or audio work, a DAS is actually a pretty cool and simple solution that doesn't require any messing around with Linux, networking, and other stuff, which might take a lot of time, research, and money, especially once you're starting to look into 10 gig networking and beyond. I filled my unit with 3 WD-RAID Plus drives and 2 2TB WD-RAID SSDs. Since the DAS is connected via Thunderbolt, I thought I'd take advantage of those SSDs and try to do some video editing off of them. But once again, spoiler alert, this didn't quite work out as expected. I initially wanted to use this QNAP Thunderbolt to SFP Plus adapter, but then I realized that since I only need 10 gigabit connection for one computer, I can just use Thunderbolt. When you connect to Macs via Thunderbolt, you can use something called Thunderbolt Bridge, which lets you access the files and services available on one device from the other one. And Thunderbolt is even faster than 10 gig and more power efficient as long as you're using a passive cable. So once we have all the hardware connected, it looks pretty janky. The D5 has this handle on top, which is very neat for lugging the unit around, but also won't let me just put my MacBook on top of the DAS. So I use the cheap laptop stand to kind of prop it on top of the unit, which honestly doesn't look very stable. This is where relatively sane and normal part of this video ends, and we're getting into kind of cursed territory. The Linux fans among you might think that I will run Linux for this project. And yes, Asahi Linux, which is the community port of Arch Linux for Apple Silicon, has gotten pretty far and gets better every day. However, as of December 2022, it's missing a lot of crucial hardware and software features, notably Thunderbolt, which is a deal breaker for me since I want to use Thunderbolt storage. So that means that we're stuck with macOS. And macOS, especially on ARM, kinda sucks when it comes to server stuff. If you thought we'd be able to use some kind of a cool and hip file system like ZFS or Btrfs, think again. Btrfs is a Linux exclusive, and the only way to get ZFS working is a community port that doesn't work super well on M1 Macs yet. Which is a shame because the TerraMaster DAS supports passing the drives to the system individually. So if you had something like a Linux NUC, that's a new one. So if you had something like an Intel NUC running Linux, you could theoretically use ZFS with this TerraMaster unit. MergeFS is also only available on Linux, and macOS alternatives such as MHDFS and UnionFS are mostly unmaintained at this point or don't work on ARM. Finally, I explored running something like UTM or Parallels and passing the individual physical drives or even the entire RAID controller to a Linux VM, but the PCIe and SATA pass-through don't seem to be supported on the M1 Macs. Now I did mention that the TerraMaster D5 is basically a RAID controller in a trenchcoat, and to be precise, it's a high-point Rocket RAID 2720. So even though hardware RAID is very much dead in 2023, Our only option is to dig out its corpse and initialize our hard drive array in hardware RAID 5. Now keep in mind that this only applies to M1 Macs. With an Intel Mac, you should be able to run something like Proxmox, Unraid or TrueNAS, provided they have Linux drivers for the networking card and the RAID controller, but alas, we're stuck with hardware RAID. Before actually starting to mess with the home server stuff, I installed a fresh copy of macOS Monterey on my MacBook and made sure to hide all applications from the dock and set the background to Windows 95 Teal. This is a server now, not a Starbucks soy latte Instagram machine. In order to eliminate the need for a stand, I also took my TerraMaster unit apart and unscrewed the handle, so if you use it with the Mac Mini, you should be able to put it on top of the DAS something like this. Then I unplugged all the internal peripherals, dimmed the internal display, waited until the laptop was fully charged, and measured the power draw. The laptop draws 5 to 6 watts from the wall at idle, which is pretty good. And at full load, running Stress NG on all 8 cores, it draws around 18 watts, which is really impressive considering that the M1 has about as high of a passmark score as Ryzen 2700. Now let's connect the TerraMaster unit. Unfortunately, it doesn't power on its own, and I basically had to press the power button every time I would disconnect and then reconnect the power adapter, which was kind of annoying. Not a big deal if you actually use the DAS for its intended purpose, but I can definitely see being a deal breaker if you want to use your server remotely. After installing the RAID Master software, I initialized the hard drives in RAID 5 and set up the SSDs in RAID 1 array. I also set the spin down timeout to 10 minutes. After that, I formatted both pools in APFS because that's what macOS works best with, connected the two laptops together with a Thunderbolt cable, and waited for the drives to spin down. Finally, I measured the consumption of the entire thing from the wall, and 19 watts. Now, considering that my terribly inefficient x86 server with 4 hard drives and 4 SSDs idles at 18 watts, that's pretty disappointing. Of course, once we take a look at the consumption under load though, and compare the actual performance of the two, the M1 clearly takes the cake. Which isn't that difficult because its opponent is literally a 6-year-old dual-core processor. So what about the storage and networking performance? Well, a bidirectional iPerf3 test showed around 10 gigabit down and 7 gigabit up, and in one direction the MacBook Air managed to push 17 gigabit per second, which is really nice. So in theory, our M1 Mac shouldn't have any issues serving the external SSD array over the network, right? And well, unfortunately the answer is no. I've tried all sort of configurations, and no matter which RAID mode I chose, I just couldn't get any decent write performance out of my drives. Sequential writes were lower than 200 megabytes per second for both RAID 1 and JBOD, with even worse random reads and writes. And that's with the amorphous disk mark running on the server itself. Running it over SMB made the results even worse and weirder. I don't think amorphous disk mark can actually reliably measure the performance over the network. RAID 0 was more or less okay, but I don't want to run my SSDs in RAID 0. And the worst part is that I got better performance connecting one of those SSDs directly to my laptop via a USB 3 to SATA adapter than in the DAS itself. The writing performance with RAID 1 was actually worse than the write speed of the hard drive array, which was really disappointing. I've tried replacing the Thunderbolt cable, switching to a different Thunderbolt port on the DAS and on the laptop itself, disconnecting the laptop from my main machine, restarting, and this is pretty much the best performance I could get out of the DAS. Reads were good, writes were abysmal. Personally, I don't know what exactly is bottlenecking the drives, but it seems to be the RAID controller. Maybe I could get better speeds by using a different direct attached storage unit, but I don't have one on hand to check. I also benchmarked the performance of the hard drive array on the TerraMaster D5, and the results were fine. Keep in mind that this is RAID 5, so you will have slightly worse performance than with individual hard drives. In general, if you're planning to get this DAS and only use it with hard drives, you shouldn't have any issues. So since it's technically a server, we need some way to manage our Mac remotely, from another machine. Now macOS is Unix.
It's a Unix system. I know this.
So after activating SSH in the system preferences, you should be able to simply SSH into your Mac and do a lot of stuff from the terminal, just like you're used to on Linux. But since macOS is primarily a desktop operating system, some things are either impossible or very difficult to do via the terminal, and you'll have to resort to GUI. And for that reason, you'll probably want some kind of remote desktop functionality. Of course, since my MacBook has a screen and a built-in keyboard, I could just do everything on the machine itself, but I wanted to do it the right way. For that, you'll need to tick this box in the system preferences to enable remote VNC connections, and after that you should be able to use any VNC client to connect to your Mac remotely. I used VNC Viewer to test it out, and it works, although it's kind of choppy. I've also tried Screens 4 because it was suggested to me by a viewer, and it worked a bit better in my experience, so you'll probably see footage from both in this video. On a headless Mac such as the Mac Mini, you might need to use a dummy HDMI plug like this one. This basically tricks the computer into thinking that there's a display connected to it and that it should output the image to this display. Otherwise, you might not get an image if you connect to your Mac remotely. I don't have a Mac Mini to test that though, so feel free to chime in the comments and correct me if I'm wrong. Finally, I installed the Xcode developer tools, Homebrew, and all the stuff that I usually install on my servers, including of course Docker. So the good thing about Docker Desktop for Mac is that thanks to Rosetta 2, it supports not just ARM64 containers but also AMD64 ones. For instance, here's BinHex Crusader, which only has an AMD64 version. The bad thing, however, is that even though macOS itself supports VLANs just fine, the Mac VLAN networking driver is broken on the macOS version of Docker as of December 2022. The Docker developers did mention that they would take it into their sprint in August, but so far there's been no news about the bug. I've also tried creating a VLAN network on the Mac itself and passing it through to a UTM virtual machine, and that worked. So if you need a separate VLAN for your services, you can run them in a Linux VM. So what kind of Docker containers can you actually run on the M1 Mac server? Well, I ran some popular ones such as Home Assistant, Grafana, Nextcloud, Jellyfin, and Nginx Proxy Manager, and all of them ran just fine. I didn't do any extensive testing and only went through each application a little bit, but at a first glance, all applications seemed pretty snappy, nothing to complain about here. M1 Macs run on the ARM64 architecture, so running Docker containers on M1 isn't that much different from running them on a Raspberry Pi, except for performance, of course. Docker Desktop for Mac runs a lightweight Linux VM based on QEMU and basically runs all Docker containers inside of it. Is it QEMU or QEMU? I don't know. I'm gonna call it QEMU. Even virtualized, the performance was pretty good and I was able to stream a 4K movie through Jellyfin without any buffering, as long as I was using Direct Play. Transcoding the 4K HDR version of Dune was a pretty miserable experience. I was only able to watch the movie from the very beginning, and that's with a lot of buffering, and skipping brought the playback to a complete halt. Though my main server is admittedly even worse at that. As of making this video, Plex supports hardware acceleration in macOS when running natively, and Jellyfin developers are working on adding the support to their media server. So with hardware acceleration, the performance should get even better. However, the world doesn't end with Docker, and there are some things that you can run on your Mac natively. Plex Media Server, for example, has a native Apple Silicon version, and if you have a Plex Pass, you should be able to use Video Toolbox for hardware video transcoding. I don't have a Plex Pass, so I've tried playing the same 4K HDR version of Dune with software transcoding, and surprisingly, it ran very smoothly and without any buffering. I was even able to skip around with no major slowdowns. Well, maybe that's because Plex is running natively and Jellyfin is running in a glorified Linux VM, you dummy. Well, that's what I thought too, but unfortunately running the AMD64 macOS build of Jellyfin didn't really improve the viewing experience. Maybe once there's an ARM64 version, the performance will get better, but for now, between Jellyfin and Plex, only the latter can reliably stream high bitrate 4K content. Another thing that I've been playing with recently is Stable Diffusion. Unless you've been living under a rock, you probably heard about all the AI-generated art stuff. And if you have an ARM-based Mac, you can self-host a Stable Diffusion toolkit such as Invoke AI, and use M1's machine learning capabilities to generate images from text prompts, such as this one. If you want to run this on Linux or Windows, you will need an external graphics card, and even with a low-tier Quattro card that's powered off of the PCIe slot, you're looking at least 15 to 20 watt power increase at idle. So for now, running it on an M1 Mac is pretty much the most power efficient way, and I can definitely see an M1 Mac being used as a relatively inexpensive and power efficient way to play with some machine learning stuff. A Minecraft server is also one thing that you could reportedly self-host natively if you have an M1 Mac. Minecraft is based on Java, and there is a build of OpenGDK by Azul that is optimized for Apple Silicon. I've seen some reports of people getting a Minecraft server to work on their M1 Macs, but haven't tried that myself, so once again, feel free to chime in the comments if you have any experience with that. Of course, you can't truly call something a server if it doesn't run virtual machines. At least that's what my comments keep telling me. And on macOS you have a few options. The first one is UTM, which is a relatively new, free and open source QEMU frontend. It runs really well on M1 Macs and lets you virtualize pretty much any ARM64 operating system. It can also emulate AMD64, 32-bit x86, and even some pretty exotic architectures like Spark, OpenRISC, and PowerPC. The list is very long. You can even run Windows XP if you want. Why? I don't know, but the possibility is there. I've tried running Ubuntu, Fedora, and even Windows on ARM, and those all work pretty well on my M1 MacBook Air. Another option is Parallels. Parallels is a more mature and polished virtualization host, but it's also paid software. I personally don't have as much experience with it since UTM has been working just fine for my virtualization needs, but I know people who prefer Parallels to UTM, and if you're one of those people, you know who you are. Keep in mind that the beefiest RAM configuration for M1 devices is 16 gigs. I don't think that any one of you was actually planning to run like dozen of VMs on an M1 Mac Mini, but in case you did, I'd personally look elsewhere. Keep in mind that even though you can remove some bloat from the macOS, you probably won't be able to get as low of RAM footprint as a server Linux distro, so you should expect up to 4 GB of memory consumption for the base system only. So as we've established in this video, the M1 Mac can be a pretty decent home server depending on your needs. It can run Docker containers, both ARM and x86, it can run virtual machines, it can be more or less a decent storage and media server provided you don't have any strong feelings about hardware RAID and don't plan to use SSDs. But at the same time, I feel like it could be so much more if it could run something like Proxmox or TrueNAS. As of December 2022, Asahi Linux doesn't support Thunderbolt just yet, which means that devices like this TerraMaster D5 Thunderbolt 3 or this 10GB SFP Plus adapter would not work. However, seeing the huge progress that the Asahi Linux developers have made since the M1 release, I have no doubt that if you're watching this video in 2023 or 2024, M1 as a Linux server with full Thunderbolt support might already be a thing. For now though, the potential of Apple Silicon for server applications is unfortunately being held back by macOS. No Linux means no ZFS, no Btrfs, no tiered storage, and no KVM. And I know that a lot of you guys can't imagine a home server without at least one of those things. One of the other things that I was kind of stoked about is power efficiency. ARM is the future, so normally the M1 should blow pretty much every x86 build out of the water in terms of power efficiency, right? And yes, with no peripherals connected, the M1 MacBook Air draws around 6 watts, which is really impressive. Unfortunately, connecting the Thunderbolt DAS brings our power consumption to 19 watts, so no matter how efficient our actual computer is, most of the power consumption is probably going to come from the storage and networking. Then there's also the upgradability and the repairability aspect. Even the desktop M1 Mac Mini comes with RAM and SSD chips that are soldered onto the motherboard. Not being able to upgrade your server when the hardware inevitably becomes obsolete, not being able to replace a failing SSD or RAM chip, and being stuck with 16 gigs of RAM, I'm willing to turn a blind eye to those things when it comes to MacBooks, where the lack of noise, compact footprint, great performance, and a long battery life leave pretty much no competition. So as much as I would like to get a laptop that ticks all of those boxes for me and has better repairability and upgradability, I can't. I already spoke about the reasons why I use Mac in this video of mine, so go check it out if you want to know more. In the desktop space, and especially for server use, where macOS is a curse rather than a blessing, you can definitely do better than the M1 Max. Sure, the 19 watts idle is fine, but if you compare it with some x86 systems from this spreadsheet, it's not exceptionally low. And even if the power consumption under load is amazing compared to some x86 builds, you have to consider all the pros and cons. Would you rather have amazing consumption under load and be stuck with 16 gigs of RAM and macOS as your server operating system, or have an okay power consumption and be able to install up to 128 gigs of RAM without selling a kidney, run Proxmox, TrueNAS, Unraid, and install any amount of hard drives and SSDs without having to buy a Thunderbolt enclosure like this one? So the only way I can really recommend an M1 Mac as a home server is if you don't need external storage or plan to ever use your M1 Mac as a NAS, don't want to use ZFS, Btrfs, KVM, or other industry standard technologies, and don't mind running macOS as your operating system and are okay with its quirks. Personally, I use my home server primarily to store my YouTube footage, and as a high-speed SSD file server that I can edit my videos off of. I also have a lot of Docker containers in it, but nothing that would necessitate a beefy CPU with a lot of cores. For me, an M1 Mac would not be any better at any of those things, and in some cases it did even worse and required more work to set up, so I'll personally stick with my x86 machine. But who knows, maybe for you M1 Mac is a perfect home server. If you use one in your home lab, let me know what you use it for. Seriously, I would love to know. So that's gonna be for this video, and as usual, I would like to thank my patrons, which I'm gonna be reading off the monitor because I forgot to put them on the teleprompter. Carlos Bonilla, David Love, James Uppington, Mitchell Valentino, Money Fan Fan, Primus, Ramos Ilyash, Robots Dream of Crypto, and everybody else supports this channel. Thank you guys for watching, and I'll see you in the next one. Goodbye.